Okay, so your next quiz, you're going to have to do this. So you got to make sure you know what you're doing. And I'm going to have a little discussion with you guys so you can help me out here. I'm going to do, I'm going to put cold on the left and warm on the right. So help me out here. What should I do? What's the first thing I could do? Somebody raise their hand. Lawrence? Add numbers. Do I really need to add numbers? Is it necessary? Is it helpful? Yeah, it's helpful. Now remember, in modeling though, anything that we can cut out, if it's not necessary, cut it out because otherwise it'll take too much time. So I could add numbers on the side to show the reading of the thermometer, but I'm trying to go quick. So what can I do next? Yeah, I would copy this stuff down. Put one level lower than the other. Cold lower and warm higher. Okay. Can I use the same color for both? Okay. So I'll put cold maybe like this, and I'll put warm like this. Is that okay? All right, what am I going to do next? Add particles. Do we need to add particles? Is that important? Particles are always important in this class, every model, right? How many particles? How many particles in the cold one? 6. Why 6? Because there's 6? Okay, I like 6 because it's not a crazy high number. Okay, 6 particles. How many in the warm? Still 6. Why? Has to be the same in each view, right? That's called the law of conservation of mass or matter. Law of conservation of matter. So I'm going to fill up all the open space, right? I don't like that one. All right. What am I going to do next? Make a what? A key? Do we need a key? I always put a key. And label. Key and label. Okay, let's start with the key. So we could call those mercury particles. We could call them alcohol particles. We could call them just liquid particles. Let's just do, we're just saying kind of liquid. All right. We got to put movement lines. What are movement lines? We got to show that they're moving, right? Are they moving the same in both thermometers? They are not moving the same in both thermometers, are they? How would you explain the difference? Okay, so cold is moving very, very slow, barely moving. And warm is moving really fast. Do you guys agree with that or anybody disagree? So how am I going to show that difference? Jacob? Little arrows on the cold. Okay, you guys agree with that? Does it matter what direction they point? Okay. So I'm going to do just little arrows here. Just picking random directions. And then here, they're going to be longer ones, right? Good. You guys had said something about labeling earlier. What would I label? Probably also have the title, right? Okay. No, because arrows just being a norm that we have established in class, we don't need to put that on the key. We just should know, right? And since you guys on the quiz or whatever, or through models we do in class, should be adding those, it's assumed that everybody knows what that is. All right. Yep. Is this missing anything else? Explanation. We gotta have some words, right? So cold thermometer, what are we saying about those particles? Moving very slow. Should have said particles. What else can we say about the particles? They are closer together. Anything else we need to say? What about the hot side over here, warm side? Particles moving fast. What else about the particles? Okay, so if the particles are spread out, this is the main idea here. If the particles are spread out, then that means the liquid does what? Expands, that's right. So if we're using the same number of particles up here, okay, but we got to fill a much bigger space, it makes sense that we're showing more space between them, and we should know that when we add heat or at higher temperatures, the particles are going to be more spread out. Eventually, they could get to the point where they turn into a gas and they're really spread out, right? So that's the main idea with the thermometers. That's what you should be able to do on your quiz next Friday. Okay? All right, good.